Okay, let's unpack this. Imagine you were trying to wire up a massive 50-story office building or, a giant sports bar, and you want flawless 4K video absolutely everywhere.
Yeah, that is a massive headache.
Right. Because you might think, oh, I'll just run extremely long copper HDMI cables. But standard copper hits a physical wall due to attenuation. Like after 40 or 50 feet, the electrical signal literally degrades from resistance. It just turns that high-frequency data into heat.
It does, yeah. To push 18 gigabits per second, which, I mean, you absolutely need that for uncompressed 4K resolution at 60 hertz, copper just can't span those commercial distances.
So that brings us to the mission for today's deep dive. We are exploring the invisible infrastructure that solves this exact bottleneck. We're basing this on the specs from the Celerity UFO-CABLE-550P.
Which is this massive 550-foot universal fiber optic extension cable.
Exactly. And we really want to figure out how cutting-edge engineering allows us to transmit massive amounts of 4K data over distances longer than a football field without a single glitch.
Well, to understand how it conquers that 550-foot gap, we kind of have to move away from traditional electronics entirely. We have to look at the physics of light.
Right, because swapping electrical pulses for light beats attenuation completely. We know fiber optics give you zero signal loss over that distance, and it completely eliminates electromagnetic interference.
Spot on. But the usability is really key here. Because it uses fiber optics rather than copper, it's completely bidirectional.
Wait, so it's like finally having a cord you can't plug in backward on the first try.
Yeah, exactly. There is no correct direction to install it. Both ends act as perfect precision optical pathways.
But wait, so this cable is literally shooting light instead of electricity to send the video. Because standard TVs and media players, they output electricity, not light.
That is the core engineering feat here, honestly. A standard HDMI port actually outputs a tiny amount of continuous power, just 5 volts. So the Celerity cable intercepts that 5-volt signal right at the connector head to run an integrated micro laser transceiver. It's actively converting electrical data into optical pulses on the fly.
Inside the actual plug?
Yes, right inside the plug, entirely powered by the source component itself. You can actually see it working because there's a little blue LED that lights up.
Wow. So the head of the cable is essentially an active microcomputer.
Precisely. Which is brilliant for avoiding installation mistakes on massive commercial projects.
Here's where it gets really interesting, though. Because shooting light through glass is amazing in theory. But how do you physically drag 550 feet of delicate fiber optic cable through the walls of a building without destroying it?
Right, because glass snaps.
Exactly. Dragging it through drywall conduits and narrow ceiling tracks sounds like a total disaster waiting to happen.
It does, which is why Celerity uses this specific universal fiber optic, or UFO, design. The bulky HDMI connector head actually detaches. Yeah, you're left with this tiny micro plug that easily pre-wires through those narrow conduits. And to keep the delicate optical lenses safe from dust during the pull, it uses these specialized protective rubber caps.
But how does a detachable head maintain the microscopic alignment needed for lasers? I mean, if those fiber lenses are off by even a fraction of a millimeter when you reattach the main head, the optical signal just drops completely.
Well, that alignment problem is solved by a proprietary locking coupler system.
Okay, how does that work?
When you snap the head back onto the pre-wired fiber line, the couplers mechanically force the internal lenses into absolute alignment. It clicks in securely, ensuring the laser hits the microscopic core of the fiber dead center every single time.
That makes sense. But what about during the actual pull through the walls? The specs list a 60-pound pull strength. I want you to imagine dragging a 60-pound weight, like a large golden retriever, by a slim fiber optic thread.
Yeah, that would not end well.
Right. Obviously, it's not just the glass handling that tension. You've got internal structural jacketing acting almost like the steel cables on a suspension bridge.
Exactly. The internal tension members take the physical load so the fragile optical core inside doesn't stretch or fracture. The mechanical load is distributed entirely away from the glass.
Wow.
And you combine that durability with an OFNP plenum-rated jacket, meaning it meets strict fire safety codes for commercial spaces, and you have an optical pathway built for heavy-duty infrastructure.
It really reframes how you look at the environments around you. Why does this matter to you listening? Well, even if you weren't dropping hundreds of dollars on a 550-foot cable today, this tech highlights the incredible hidden infrastructure making our seamless high-definition world possible.
Yeah, if we connect this to the bigger picture, we are witnessing a complete architectural shift from electrical to optical infrastructure, specifically to bypass the physical laws of resistance.
Which leaves you with an incredible thought to walk away with. If we can seamlessly shoot 18 gigabits of data a second across 550 feet of glass thread today using these tiny self-powered optical heads,
Right.
what happens when this kind of detachable light-speed microtechnology moves from the walls of our buildings to replacing the copper wiring inside our everyday personal devices?